suppose A is a subset of 1, 2, 3, okay, in general.
Yeah.
How many A's do we have? How many subsets are there for 1, 2, 3?
3 to the power, sorry, 2 to the power of 3, so 8.
Yes, the reason is what?
And that's just the number of subsets. And
Yes, and the
so,
reason is what?
yeah,
That we have two cube
yes.
subsets.
So the number of subsets for two elements in it is gonna be what? Like n choose 2. For 3 elements, we're gonna choose 3, and then
You use
and
that. Okay, let me tell
subset.
you an easier way. Look, tell me a subset from this, any subset, an example.
2, 3.
Is 2, 3. When you say 2, 3, you are doing what? You say 2, 3.
Yeah,
It means that
2,
1 cross, 2 check, 3 check, right?
yeah,
So do you agree for each element you can select it or not? Cross check, cross check,
yeah,
cross check. So two
yeah.
ways, two ways, two ways, 2 cubed, right?
Oh, yeah, that's true.
Okay, it is a reason. It means that we consider from elements. Now suppose we have two subsets. A, B from 1 to 3. How many A and B are there? We want to select both A and B together. So one subset here, one subset. How many ways are there for selecting A and B?
For selecting A and B, so do they have to be distinct, right?
Do they what?
Distinct.
Not necessary.
Okay. Is it 2 to the n choose 1 times 2?
Let's
I
consider.
mean,
Look,
whole
we should
squared, I meant.
select both A and B. For A, how many options do we have? For B, how many options?
For A, we have 2 to the n options.
Yes, here 2
B, we
cubed
have
times
2 to the 3 as well, so whole squared.
what?
So it's 64.
Exactly, 2 to the 6 is 64. But let me tell you, this was solution 1. Let me tell you another solution. This solution is important. So here, look, we consider these from subsets, right? We said A22, B22. Now we want to consider from elements. We consider from the elements. For here, look, when we had one subset, we said, okay, for each element, we have cross-check, right?
Yeah.
Now we have two subsets. For each element, how many cases are there? For example, one case is cross-cross. What else?
What do you mean?
Look, for example, here, we said for one, we have check cross, right?
Yeah, yeah,
2 check cross, 3 check cross. Now here we want to select two subsets, right?
yeah.
So can you tell me one example? A is what, B is what?
Like elements?
Yes, an example. Like here you said A23. Here we have two subsets. So A is what, B is what?
Let's say A is like 1.
B is what?
1, 2.
1. So now let's check. For 1, it is check check, right? For
Yeah,
2, cross check. 2 is not in A but is in B, right?
yeah.
For 3, it's what?
Cross, cross.
Exactly. Now here, for each element, how many ways are there for going to A and B?
2.
Can you tell me two? I said cross, cross. What else?
Wait,
For
what do
each
you mean
element,
by,
look, each element can be in none
yeah,
of them or
yeah,
only in A, right? What else?
yeah. Could be in both. And
Yes,
could be in B,
in
could not be in
only
A,
B
yeah.
or both. So each element has
Yeah.
how many cases for going to A and B?
4? 4
4. So
cases?
element 1 has 4 cases, element 2 4 cases, element 3 4 cases. Which is what?
4 to the 4 cubed. 64.
For exactly again 64. Now maybe you say, okay, here also we could reach 64. Why we use all these things? Because in most of the problems like this, you have to use solution 2. With solution 1, we cannot solve. Okay, let me tell you an example. Suppose A is subset of B is subset of 1, 2, 3. So how many A and B are there? Try this one.
Okay. Is it 56?
Can you explain your solution?
So for B, since A has to be a subset of B, So
Yes.
first I just like B. We can choose B 8 ways, right? There are 8 choices for
For
B.
B, 8 ways, but they are
8.
different. For example, if
Yeah.
B has 3 elements, then A has how many cases?
It can have either those 3 elements or the elements choose 2 and elements choose 1.
You can say 2 cubed. A has 2 cubed because
Yeah.
for each of them can be inside it or outside it, right?
Yeah. Yeah.
So for this case, we say 3 choose 3 for B and for A 2
Yeah.
cubed, right?
Yeah.
Choose 2 cubed. If B has 2 cases, 2 elements, then A has how many cases?
That case 2 squared.
2 squared. So in this case, for B, how many cases are there?
So for B, 3 choose 2. 3
Yes,
ways.
good job. 3 choose 2 for A,
2 squares. 4.
3 times 4, 12. For B, 1 case, A has how many cases?
2 cases.
Yes, so it will be what here?
So 6 ways for B.
6 ways. For
3
B,
choose 1.
yes,
Uh,
3 choose 1.
oh,
1,
3.
3 ways
Just 3.
for this and 2 and
3.
6 in total, right?
Yeah.
If B has
6.
no
Yeah.
elements, then A,
1.
yes, 1 way or 2 cases. Here, 1 times 1, 1, right? Some of them
Yeah.
it was.
Oh, 27.
Now look, and the idea if inside 3 elements we had 4, 5, it was harder, right?
Yeah.
But let's solve with double counting, means changing viewing angle. We want to consider instead of the subsets from the elements. So can you tell me, A is a subset of B. For each element, how many ways are there for going to A and B? Cross, cross, check, check, like, what are the cases?
To choose the elements.
Look like previous one. For example, previous one you said for A, for each element for going to AB, cross, cross, check, cross, cross, check, check, check,
Yeah.
right? Now here we
Yeah.
have a condition. So which of these 4 cases are acceptable here?
Whatever is in B has to be in A.
Yeah, so tell me, for example, one case, one good case is check, 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 check is. Tell me other good case.
So B check, A cross.
B check, A cross, yes, what else?
Um, cross cross.
Yes, only check cross is bad, right?
Yeah, that's bad.
So each element has 3 cases. So the answer is what?
3 times 3 is 9.
3 times 3 times 3, right?
Oh yeah.
Or 1, 3. Yeah, this solution is easier.
Yeah, it's yeah.
Exactly. So here now, similarly, for example, A subset of B subset of 1 to 10. Then how many A's? So this one was 20. So here, number of A and B are what?
The number of ways we can choose A
How
and
many?
B.
Yes, how many A and B's are there? Only I changed 3 to 10.
Yeah.
Same. So it will
So
be what?
3 to D10.
Exactly. Now, again, we want to solve similar problem here. Instead of 2 subsets, let's consider 3 subsets. 1 to 10. Now here, number of ABC are. How many ABCs are there? Try this.
Okay. I got 4 to D10.
4 to the 10, you said, right?
Yeah.
Good job. I think it is something like this. If from here we have check, 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 check. If it starts from here, it will be this, or starts from C, or none of them. So 4 to the 10, right? Okay, now you've learned this idea and you are ready to solve problem 20. So let's consider. It says let k be the number of sequences a1, a2 to an, such that n is a positive integer divisor, integer less than or equal to 10. So n is at least 1, at most 10. Each ai is a subset of 1 to 10. ai minus 1 is a subset of ai for each I between 2 and n. So let me ask you something. I told you the most useful idea is what?
For this problem,
In
small
general, a
polynomial.
small example, right?
Yeah.
Checking a small case. So here we can use a small example on what?
A1.
N. If
Oh,
n
for
is
n,
1,
so
the
1.
answer is what? It means we have only one subset from 1 to 10.
Yeah.
How many subsets are there?
And choose 1, 10.
No, A1. A1 is a subset of 1 to 10. How many subsets are there?
Oh, okay. So there's 2 to the 10th.
Exactly. For n2, it says ai minus 1 is subset of ai. So a1 is subset of a2, is subset of 1 to 10. How many ways are there?
3 to the 10th.
For n3, it is what?
Oh, so it's going to be 4 to the 10th.
Yes, similarly, all the way to n10 is what?
9 to the 10th.
Pay attention.
Sorry, 11 to the 10th.
Yes. And it says fine. K, so k is what? Sum of them, right?
Yeah.
2 to the 10 plus 3 to the 10, all the way to 11 to the 10. It says one's digit of k is what? So calculate one's digit of k.
Is it 5? I got 5.
Okay, let's check. I think it was 5. So because let's write all of them first. 2 to the 10, 3 to the 10, 4 to the 10, 5 to the 10, 6 to the 10, 7 to the 10, 8 to the 10, 9 to the 10, 11, 10, 10, 11 to the 10. Okay. And do you know if you want to find the remainder when it's divisible by 10, we should calculate mod what?
10.
Yes. This one is 0, this one is 1, right?
Yeah.
Okay. Now for 6, it is 6, right? For 5, it is 5. Let's write it here.
Yeah.
For 99981, it's 1, right? Let me tell you something. For 2, do you agree because the power is 10? 2 to the 10
Yeah.
and 8 to the 10 are equal?
Yeah.
Because 8 is negative 2. So for 2, if you
Yeah.
find this 2 for 8, 16, which is 6, and again 2 for 8, 16. So it's 4.
Yeah.
So because this one is 4, this one also is 4.
Yeah.
For 3, it's, again, the period is 4. So 3, 9. And this one, the period is 4, 6, 4, 6 is 6. 7 is similar to 3 is 9. So 1 plus 1, 2, 2 plus 4, 6. 6 plus 9, 15. So we can consider 5, 5 plus 6, 11,
Yeah.
1. 1 plus 5, 6. 6 plus 6, 12. 2, 2 plus 9, 11. 1, 1 plus 4, 5. Good job.